Okay, so we are going to take the derivative of tangent. So first things first, we want to remember that tangent is equal to the sine of x divided by the cosine of x. It's crucial to split these up like that before you take their derivatives. So now y is equal to sine x over cosine x. So now we can simply take the derivative of this using the quotient rule. So we already know the derivatives of sine and cosine from an earlier lesson. So we know that, so u equals the sine of x, v is equal to the cosine of x, u prime, the derivative of sine is cosine x, and v prime, the derivative of cosine x, is negative sine of x. So, using the formula for the quotient rule, we know that y prime is going to be equal to u prime times v, so cosine x times cosine x, or cosine squared x, minus v prime times u, so minus negative sine squared x, or in other words plus sine squared x, and all of that is going to be over cosine squared x. Now, if you remember the properties of trig functions that we learned last year in pre-calculus, you will recognize that cosine squared x plus the sine squared x is equal to 1. So we can rewrite this fraction as 1 over cosine squared x. And this is equivalent to secant squared of x. And that is the derivative of tangent. So if you work each of the trig functions out, knowing cosine and sine, which we learned from previous lessons, you will find that these are the derivatives of each of the trig functions.
Alright, we're done.
Okay, so now we're going to do an example problem using tangent. So the question is, find y prime if y equals tangent of x squared. So we remember from the previous segment that the derivative of tangent is secant squared of x. But now we have an outside and an inside function, so the chain rule applies here as well. So we're going to start off with y prime is equal to secant squared of x squared, because that's the derivative of tangent. But keeping chain rule in mind, we now have to multiply by 2x. So the answer to this problem is y prime equals 2x times secant squared of x squared.
Okay, so on this problem, we're going to be using trig functions and the chain rule. I wrote out the trig functions at the top because we already know what those are from before. And to do the chain rule, all we need to do to find y prime is, so first we need to take the derivative of the outside and keep the inside the same. So the derivative of tan is secant squared x. And then we keep the inside the same still. And then for the next part, we go to the next inner piece, or outer piece, and we use the derivative of sine to get cosine, but we keep the inside the same still, so it's cosine 3x. And then we go to the most inner piece and find the derivative of 3x, and that comes out just to be 3. So for this, all we need to do is tidy it up a little bit. So I'm just going to rearrange it. And this is our answer for y prime. There's no other way to simplify it, and that's about it on that problem. So on this problem, y equals secant x tangent x, and we need to find y prime. And for this, we're going to be using the product rule because it's two functions multiplying together. So for the product rule, we use if y equals uv, then y prime equals u prime v plus u v prime. So our u in this case is secant x, and I wrote out the derivatives at the top again. So u prime equals secant x tangent x, and then v equals tan x, and v prime equals secant squared x. Okay, so now all we need to do is plug into the product rule, and to do this, u prime is secant x tangent x, so we plug that in, times v, which is tan x, plus u, which is secant x, and v prime, which is secant squared x. So all we need to do is tidy this one up a little bit too. Comes out to be secant x tan squared x plus secant cubed x. And if we wanted to, we could take this problem a step further to simplify it, but it's not really necessary because it brings out the problem. It just makes it a little longer. But if we did that, it would be secant x multiplied by tan squared x plus secant squared x. And that's about all we need to know about trig functions.